Ever wondered how Java interacts with databases? It's all done through JDBC, or Java Database Connectivity. This is a standard Java API that provides database-independent connectivity between the Java programming language and a wide range of databases. JDBC essentially allows you to execute SQL statements and retrieve data from databases. It's a vital tool when you're developing Java applications that need to interact with relational databases. The JDBC API primarily involves 5 components. The DriverManager class, which manages a list of database drivers. The driver interface that handles the communication with the database server. The connection interface, which has all the methods for contacting a database. The statement interface, which you'll use to execute SQL queries with the database. And finally, the ResultSet interface that represents the result set of a SQL query. So JDBC is the bridge between Java and databases, allowing your applications to store, modify, and retrieve data. The first step to communicate with a database using JDBC is loading the JDBC driver. This is essentially your application's way of saying, hey, I'm going to be talking to a database, so I need the right tools to do that. And the tool in this case is the JDBC driver. Loading a JDBC driver is done using the Class.forName method in Java. This method is used to load the driver class file into memory at the runtime, making the JDBC driver available for your application to use. Here's where it gets a little database specific. Each database has its own driver. For example, if you're working with a MySQL database, you will use the MySQL JDBC driver. If you're working with an Oracle database, you'll use the Oracle JDBC driver and so forth. So you'll replace the parameter in Class.forName method with the class name of your database's JDBC driver. Once the driver is loaded, you're set to establish a connection with your database. Now, it's time to establish a connection with your database. To do this, we'll be using the DriverManager's getConnection method. This is where the DriverManager really steps into the spotlight. Acting as a kind of switchboard operator, it matches connection requests from your Java application with the appropriate database driver, using communication sub-protocols. So, let's envision this process. Imagine you're at a party. You've just entered the room and you're searching for a friend. The DriverManager is the helpful host who spots you, understands your quest, and connects you with the friend you're looking for. In this scenario, your friend represents the database you wish to interact with. Now back to the code. The getConnection method requires 3 parameters: a URL, a username, and a password. The URL specifies the database to which you want to connect, while the username and password authenticate your access. The URL usually has a specific structure. It starts with JDBC, followed by the subprotocol, which is typically the name of the database management system. In our case, let's say it's MySQL. Then comes the subname, which could be the name of the database. So it might look something like this: jdbc.mysql, localhost, your database name. The second and third parameters are your username and password respectively. Replace your database name, username, and password with your actual database details. Here's a crucial point. Be absolutely sure to replace these details accurately. If there's a mismatch, your application will not be able to establish a connection, and that's a party no one wants to attend. Remember, establishing a connection is like creating a bridge between your Java application and the database. It's the critical link that allows for communication and data exchange. Once you've established this connection, pat yourself on the back. You've successfully completed a fundamental step in communicating with databases using JDBC. With the connection established, we can now create a statement object to run SQL queries. But we'll dive into that in the next scene. For now, take a moment to appreciate the connection you've just made. It's a significant stride in your journey into the world of Java database connectivity. Having a connection is great, but it's not much use without a statement to execute. Now that we have a live connection to our database, it's time to create a statement and start interacting. A statement in JDBC is an object that represents a SQL command you'd like to execute. Creating a statement is straightforward. You use the connection object and call its create statement method like so. Statement equals sign connection.create statement. With our statement object ready, we can now execute SQL queries. JDBC provides us with 2 main methods for this: execute query and execute update. Execute query is used for SQL queries that retrieve data. This method executes the given SQL statement and returns a ResultSet object. For instance, if you want to retrieve all records from a table named employees, you would do something like this. ResultSet equals sign statement, execute query, select asterisk from employees. The ResultSet object then allows you to iterate over the results of your query, row by row. On the other hand, execute update is used for SQL statements that modify data. These are your insert, update, delete statements. For example, to insert a new record into the employees table, you would use int rows affected equals sign statement. Execute update, insert into employees values, 1, John, Doe. Unlike execute query, execute update returns an integer representing the number of rows affected by the query. This gives you an immediate feedback on the impact of your SQL statement. So to recap, we use execute query for select statements and execute update for insert, update, and delete statements. These methods enable us to interact with our database, retrieving and modifying data as needed. But remember, these statements are powerful tools. With great power comes great responsibility. Always double-check your SQL commands before running them, as they can have significant effects on your database. After executing your queries, it's vital to remember one last step: closing connections. Closing connections and handling exceptions are crucial aspects of database interaction. Let's delve into why this is so important and how to effectively handle these aspects. After executing our operations, it's paramount that we close the database connections, statements, and result sets. You might wonder, why is this so important? Well, every time you establish a connection or create a statement, it consumes resources. These resources are finite, and if not properly managed, they can quickly run out, causing your application to slow down or even crash. So, by closing these connections and statements, we're effectively freeing up these resources for future use. Now, how do we close these connections? It's simple. For each of the connection, statement, and result set objects, we call the close method. For instance, if we have a connection object named con, we would simply call con.close. The same goes for statement and result set objects. Moving on to exceptions, these are events that occur during the execution of programs that disrupt the normal flow of instructions. In the context of JDBC, the SQL exception is the one we're most interested in. This exception provides information on database access errors or other errors with the database. It's important to note that SQL exception is a checked exception. This means the Java compiler forces us to handle these exceptions, either with a try-catch block or by declaring it using the throws keyword. This is a good thing because it ensures that we don't ignore these crucial errors. So when we're executing our SQL statements or when we're interacting with the database, we should always be prepared to catch these SQL exceptions, handle them appropriately, and perhaps most importantly, learn from them to prevent similar errors in the future. By handling exceptions and closing connections, you ensure the efficiency and security of your database operations. So next time you're working on a JDBC project, remember these two crucial aspects. They could be the difference between an efficient, secure application and one that's prone to crashes and security breaches. So that's the process of communicating with a database using JDBC, broken down into simple steps. A recap for good measure never hurts, right? We started with loading the JDBC driver, a crucial first step that sets the stage for our Java application to communicate with the database. Remember, each database has its own driver, and we must initialize it using the Class.forName method. Next, we established a connection to the database through the DriverManager.getConnection method. This step is akin to dialing a friend's number on your phone. You're setting up a line of communication, but instead of a phone number, you're using your database details. Once the connection was established, we created a statement object. This step is like picking a topic to discuss with your friend on the phone. In our case, the topic is the SQL query we want to run on the database. After forming our statement, we executed the query. This is the heart of the conversation, where we ask the database for information or tell it to perform an action. Remember, we use the execute query method for SQL queries that return data and execute update for SQL statements that could change entries. Finally, we wrapped up by closing the connections and handling exceptions. It's like hanging up the phone after a chat. This step is vital to free up resources and ensure smooth operations. And of course, don't forget to handle those exceptions, especially SQL exception, which provides valuable information on database access errors or other errors related to the database. Throughout this process, we've seen how JDBC provides a robust, database-independent method for querying and interacting with databases. It's like having a universal translator for databases, allowing our Java applications to speak the language of any database we choose to interact with. With JDBC, Java applications can interact seamlessly with databases, making it an essential tool for any Java developer. Happy coding!